Let us continue our session with IP Office of the Future. Let me introduce to our speakers. We're working in a hybrid mode, and present here, online and offline, are Heli Pichlayama, Director of Patent Law, European Patent Office; Xinjiang, AI expert, Deputy Director General of Automation Department, CNIPA; Elen Nikora, Chief Representative Officer for Europe International Trademark Association; Valentin Painko, Head of Mechanics, Physics and Electrical Engineering, Eurasian Patent Office; Konstantin Nagaev, Deputy Director, Federal Institute of Industrial Property; and finally, Mikhail Salnikov, Head Physics and Applied Mechanics Department from the FIPS. Colleagues, we have 1 hour 20 minutes for all our discussion. Therefore, we have to understand what and how the IP Office of the Future would look like. So please be brief, and then we'll really understand what awaits us in future. Several years ago, Russia adopted the strategy for the development of digital society with the main objective to build the knowledge-based society. The economy of knowledge values intangible assets such as IPs. Therefore, the IP offices certainly play an important role. We all are building new infrastructure. We are training experts. We have new objectives. And the means and ways we lived with before certainly would not be appropriate to provide for the digital economy and new ways of our life. Every department, every agency, this way, that way, would use technologies and algorithms based on AI in their activity. This is about the patent search, pre-search, the image search, some training mechanisms, chatbots, which are being set up for the users. Moreover, we have another quite important area that's about the examination of applications for AI-based technologies. These are the things which we're going to consider at our session. I hope that, at least I want to believe, that IP offices would stay with us forever and never will bring together artificial intelligence and IP into one agency, which may translate into artificial IP. And how offices are going to work to this end, and how the IP offices are going to look in future, this is what we're going to discuss. Recently, INTA proposed certain strategy in that area. Elen Nikora, Chief Representative Officer for Europe International Trademark Association. Over to you, Elen.
Thank you so much. Can you hear me well?
We can hear you. Thank you.
Fantastic. So thank you so much for Rospatent to invite me today to speak and contribute on this very important subject. At INTA, I'm directing the Europe office, and also I'm the staff in charge of supporting the association with a key project on the IP Office of the Future. So let me just take a few minutes to introduce you to this project before diving in the key findings of this project when it comes to the use of AI by the IP Office of the Future. So back in 2019, INTA was actually approached by several IP offices to seek guidance on their national strategies, but also on challenges and responsibilities they should foresee. And in that context, INTA decided to create an independent think tank composed of experts, current and former heads of IP offices from Australia, Canada, Chile, France, the European Patent Office, India, Mexico, the Philippines, Singapore, South Africa, Uganda, and the United States. And as you can see from the geographical diversity of the think tank, we ensured that the views of all the think tank was representing all types of IP offices, no matter their size and no matter the challenges that they were facing. So the think tank produced a report, an independent and thought-provoking report of what an IP office in the future would look like in the 10 to 15 years from now. And I'm here to share the findings of that report with you, but I am under no circumstances speaking on behalf of the experts of the think tank. So at INTA, we also realized that we needed two other think tanks to complete that one on the in-house teams of the future and one on the law firm of the future, to gain a holistic view on where the evolution of the IP community could go. And the three reports are available on the INTA.org website. When it comes to the use, the IP Office of the Future report, it addresses a variety of topics. It portrays the evolution of the IP system, future challenges and opportunities that IP offices are facing, and more interestingly, it looks at the evolution, the potential evolution of the rules an IP will be able to endorse in the future, whether it's traditional rules or non-traditional rules. Before closing with a case study of how IP offices can actually survive and thrive through pandemics or crises such as the one we are currently living in. So the report identifies traditional roles, such as administering and managing IP rights with optimal pendency, stewardship, human resources, financial resources, or harmonization of IP law and using new technologies to adapt services. More interestingly, when it comes to non-traditional roles, which are varying from an office to another, and which are very specific to each IP offices, they tend to include connecting with across stakeholders, supporting research and innovation, leveraging market efficiency with ownership information, supporting IP evaluation, supporting IP enforcement, supporting awareness and education on IP benefits, also informing and supporting policy development, becoming a data-driven office, and interestingly, also enabling AI and disruptive technologies. So according to the report, enabling AI and disruptive technologies is part of the non-traditional role the IP of the future should consider. The report concludes that there's no one-size-fits-all approach for IP offices when it comes to project themselves in the future and anticipate or respond to challenges. Indeed, every IP office is different, whether in terms of challenges they are facing, human and financial resource they have, different mandates, different historical context, or economic and social imperatives. And this is important to take in note when considering how the IP office of the future should use AI. And while we heard from this morning that Rospatent is one of the most advanced offices when it comes to AI and has a lot of things in the pipeline about how to use AI to the benefits of its users, it's important to recognize that not every IP office will use AI in the same way because of all those specific contexts and differences. When it comes to the use of AI by the IP office of the future, I mean, the report addressed many subjects, but it's worth noting that AI was really one of the key topics that was discussed by the think tank at length. And what's fascinating to note is that you have 14 current and heads of IP offices from all across the world agreeing unanimously on the fact that AI is a must for the IP office of the future. Actually, the report acknowledged that AI impacts and will impact the relevance and effectiveness of the IP system, but it goes even further by identifying advantages that IP offices will have and will gain by using AI, even recommending IP offices to immediately assimilate AI in their workflow. So rather than advocating for a more precautionary approach, as if there is a sense of urgency, and I would even dare to say a sense of irreversibility for IP offices in the future to use AI. The report, of course, identified a series of potential uses of AI by the IP office, both for internal operations, but also external services provided to users, searching, granting, managing IP rights using AI, of course, has the potential to create consistency, gaining speed also without sacrificing quality. And I'm sure all the panelists will cover such use in much more details. But what's interesting is that the report quotes WIPO's list of AI initiatives supported by its member states that demonstrate that primary use of AI by IP offices include assisting in translation, stakeholders, trademark databases, searches, patentability examination searches, and automatic patent classification. And when looking at all those potential uses, whether it's related to classification, search, image search, prior art search, etc., analyzing novelty, enabling assessment of level of distinctiveness, or enabling trademark comparison. When it comes to support on examination, or even, some IP offices have developed automate patent application process drafting. The report reached the conclusion that the use of AI gives the capacity to provide new, expeditious, and also personalized service to stakeholders who are having different needs. And it also enabled to reduce tension between timeliness and quality of IP processes. Also, the report stresses the impact that AI can have on IP rights per se, with a specific focus on patents. It raised the question as to whether the current IP framework should be amended to incorporate, for instance, AI-based inventions, and whether AI-based inventions actually deserve or are eligible for IP protection. And we have now a few decisions that are against granting inventorship rights to a creativity machine, but it is important that the rules for patentability, something that the report stresses at length, is that the rules for patentability be consistent, well understood, and harmonized across jurisdictions. Also, according to the think tank, the degree to which the use of AI will affect established IP rights, whether it's patents, but also trademarks and copyrights, is uncertain. But the think tank has a confidence in the capacity of long-established principles of IP laws, such as those defining thresholds regarding originality and disclosure requirements, to provide built-in means for the IP framework to adapt to new realities, as it's been done in the past with other disruptive technologies, such as the internet. Also, worth noting is that the report acknowledged that the use of AI will have an impact on human resources. And that's something the IP of the future needs to consider. As machines become more sophisticated and move to more predictive analysis, they will be able to implement simple decision points that were previously made by humans. So automation brought by AI will free workers, such as examiners, to focus on more intellectually intensive tasks, but also liberating resources to be applied to other work streams. There might be also a need to consider introducing safeguard mechanism like a human intervention to avoid errors. And AI, as stressed in the report, can really lead to significant changes, even reduction in the scope of an IP's function. But the IP of the future will never fight that change. On the contrary, it will have to embrace it. New skills will be needed. So in that sense, AI should not be seen as a threat, but as an opportunity for job retraining and transfer and expansion of services. And because AI application learn by analyzing vast amounts of data, and data is central to supporting AI implementation, the IP of the future will need to make sure that it uses the largest database sets to provide a mature model for data dissemination, and that might require hiring data experts and officers. Finally, last point, I just want to stress that the use of AI can also lead or reinforce non-traditional roles of IP offices. We've seen that it's, for example, going to reinforce the role of being a data-driven organization, with the office having to put in place the adequate structure to facilitate the deployment of AI. But it also will ask the IP of the future to provide policy expertise on the impact of AI on that AI can have on IP rights, to ensure that there's the adequate legal and regulatory framework for AI to deploy. And last but not least, it really pushed the IP office to increase its collaboration with other IP offices and stakeholders. There's clear need to exchange expertise with counterparts IP offices, to also exchange on challenges resulting from AI-generated invention or AI-based tools, and ideally, IP offices will collaborate together even more on IT and shared AI-based tools. Otherwise, we run the risk of a lack of consistency, coherency, and interoperability of AI-based services and systems used by IP offices. And this is essential in the sense that it can impact and lead to practice inconsistencies. So in a nutshell, it seems that AI will be a mandatory and essential part of the technological environment in which the IP office of the future will operate, and that the IP office of the future will be asked to be an enabler and a champion of change by fully adapting, embracing, and implementing this new technology to gain efficiency on the delivery of IP services and become more agile, high-performing, while at the same time considering all its potential consequences, especially on human resources, quality, timeliness, and consistency of its services. Спасибо.
Thank you, Helen. You said that the agencies will have to start using AI. You know, I think we would make this the motto of this session. Yes, the agencies of the Office of the Future will have to start using AI, whether they like it or not. Quite often, we in our work deal with the national IP offices, but still the role of regional offices has been growing from day to day, from year to year. So, are there any specialties in AI application at the regional level? Let us listen to our colleague, Valentin Panko. Valentin, head of Mechanics of Physics and Electrotechnics of Electrical Engineering, Eurasian Patent Office. Yes, please launch my presentation. Good morning, good afternoon, dear colleagues. I'm from the Eurasian Patent Office. I would like to thank the organizers for the honor and privilege to share the view of the Eurasian Patent Office on how abilities of AI can be used to improve business processes at agencies, to raise the quality of patent experts' assessment. So, the heading of this session is the Patent Office of the Future. My presentation in this respect will be slightly off-topic, because I'm going to focus more not on the Patent Office of the Future, but on the Patent Office of today, about the Eurasian Patent Office, and about the challenges and the problems, and maybe some wins we have been facing, we have been making, as we implement elements of the AI in our everyday work. We all know that using AI in the sphere of IP is very broad. And I would like to structure these technologies into two major groups. On one hand is AI application for standards, challenges faced not only by patent offices, but by any business structures, by any entities. be it financial planning or business analytics or administrative issues. And in this respect, we have various solutions available which can be used in everyday work. And then I would like to offer another group, tasks which are specific for the patent sphere. And this sounds close to me because I'm head of the department related to expert estimate of inventions. And here we pin big hopes on systems, on AI systems, and on using AI systems for purpose of improving patent assessment, for extending the range of possibilities offered to our applicants, for instance, invention classification, or better quality of application expert assessment, or elements of AI to be used in automatic search for relevant documents. So systems of this kind, as we all know, have been announced and have been scheduled for implementation by the world's largest offices and agencies. And we even see working systems that rely on AI. We, as the regional office, are also participating in this trend, the trend which will use AI elements in our routine work. Where does this all begin? How do we begin any selection, any strategy? We begin by assessing the issues and problems that we're going to face. These problems could also be classified into two main classes. It's the general problems related to AI implementation, problems which affect all the participants of the market. For instance, the skills of human resources in the AI sphere. We all know that systems based on AI call for special skills and qualifications in this particular area. Another problem is availability of data which can be used for training neural networks. And usually when we talk about AI elements, we must often refer to neural networks and the capacity offered by machine learning and deep learning. Furthermore, we should also bear in mind when we analyze and plan our strategies, we need to remember failures of AI implementation. And before we invest significant amounts into deploying AI systems, we need to analyze whether they are going to be effective first. And in view of this, we need to estimate the cost of preliminary development, because it is no secret that quite often money invested in developing such large-scale systems can be more significant than the payback on the investment of this system. Furthermore, there's another class of problems which are specific for the patent sphere. One is a lack of universal methods and developments designed to solve tasks related to the intellectual property. That would give us indisputably acceptable level of quality. Furthermore, there's another problem. We can only share technologies of AI to a limited extent between various agencies, because usually agencies rely on proprietary systems that have been developed for the respective corporation. Agencies cannot share due to language barriers, but also due to legal barriers and document processing regulations. And this generates problems related to the difficulties of identifying what would be the advantage of using AI-based systems over the existing systems. Let's call them conventional systems. of automation of business processes. At the same time, as the previous speaker, our guest has said, there's no way we can avoid using AI. It's a given. And we all know that this technology offers advantages. We know how effective this technology is. Solutions on the basis of AI have already proven the effectiveness in many industries. Quite often, such solutions are the only possible way to automate particular processes, such as image recognition, speech recognition, the text analysis, etc. And this offers us a broad range of good field for optimism. Now, clearly, patent offices cannot afford ignoring this powerful technology. Clearly, we must use any opportunity to use any technology that can potentially improve our patent expert assessment, including the time it takes to assess applications and to extend other services. Now, the advantage that the present technology offers, that the digital world gives us, the world based on data exchange gives us, is the availability of resources that help us to develop our own tools in the area of AI. In the first panel, the representative of Yandex said that they upload a lot of open data and open codes into public domain. These are programs that help to develop your own systems without the necessity to invest in preliminary research and development. Now, in view of what I have said, we have taken into account all this when we were drafting the strategy of the European Patent Office in the area of AI. As for the main challenges that we faced, they include, first of all, the scale of the project, which calls for additional funding, but also for higher skills of the personnel involved. And implementation of these solutions can only be considered effective if it serves very concrete tasks related to improvement of the office's performance. We at the agency have at our disposal need to have at our disposal a certain amount of structured data to do machine training. In view of this, the EPA at the moment has already accumulated sufficient structured patent information, more than 850 patent documents, which we can use to train our systems. We have already an experienced team of developers that were involved in creating the existing services. As a result, we can hope that we will be able to implement projects of this scale. That said, the size of our office prevents us from developing systems from scratch. We cannot afford drafting a large-scale system from scratch. Therefore, for our organization, it was a priority to implement components of AI into the existing systems, the systems that we at the EPA have already been using. For instance, our IAPATIS search system. It will rely, among other things, on these elements. In view of this, we have structured our roadmap related to the strategy of implementation of AI into several conventional stages, if I may. Stage one So a testing of the available opportunities and our capacity that we need to implement these projects. We identified the bottlenecks and the drawbacks. We have expanded the bottlenecks, we have covered the drawbacks and eliminated these problems for the sake of next steps. To test our system, we selected technology for machine translation of Russian language data sets into other languages. The results of the translation itself were not satisfactory, I'll be quite honest. But we found the bottlenecks in our systems. Now, stage 2. At this stage, we used AI and we created a vector model for searching such documents. And this is where we deployed neural networks on our systems. And we trained this network on our data, the Russian language data, which we have. And then, during stage 3, we use this working vector model to implement a number of services. Services based on our existing systems that based on the preliminary pre-classification of patent documents, on pre-search of relevant documents at this stage of European Patent Office application. We implemented an online service that helps us to use any formatted text. You upload this text online into the service, and you receive all the solutions that meet this text. Well, I understand that I'm slightly exceeding my schedule. I'm not going to focus on this stage for a long time. All I want to say now that clearly we will not stop at these 3 stages. It's project work. It is only the beginning. Then it reaches a certain phase. We analyze our mistakes, we analyze the results. It's just the input data for the next stage, for a new level of our achievements, if I may say so, for our technologies. Well, clearly in the future we will consider implementing AI in such areas as interaction with the user. Our IAPV online system, our IAPV mobile system, which we launched a short time ago. We also have new IP assets, utility models. We're going to look at how we can automate the tasks related to considering applications for utility design, let's say search for images. Well, basically, that's how it is. Yes, thank you. Dear colleagues, in the previous conference, we used this term of digital human a lot. I don't like this formula because I think that human is an analog person. But I do like the term digital patent. What is the role of artificial intelligence in launching digital ROS patent? I think Konstantin Nagaev, deputy head of the Federal Institute of Intellectual Property, is going to tell us. Yes, good afternoon, good morning, dear colleagues. I'm deputy director of the Federal Institute of Intellectual Property. I'm in charge of digital technologies, information technologies. I would like to tell you about our solutions, our approaches in ITs IT systems used for AI. As part of the digital program for Russian Federation, we at HIPS have been developing a number of end-to-end technologies using neural networks and other systems. At the moment, this new system of intellectual expert assessment is undergoing test runs, and we're using this alongside the existing system. This IT uses AI to implement a number of functions. Automatic recognition of words and signs of trademark, and automatic generation of prompts. Each trademark that is entered into the system should be analyzed based on the words and the images using the International WIN classification. Previously, all these operations were done manually. The new system creates these indices automatically right after the application is filed. So now it is done after the expert on the prompts does the indexation. Then, signs are classified as follows. Pre-trained neural network, which was finally trained based on the massive trademarks. To identify the word elements, it was intended to use the tesseract mechanism. And then we saw that to reduce the noise, it would be better to identify areas with text. And to this end, we use Craft, which proved its best results with trademarks. As a result of this pre-processing, the quality raised, but then with some untypical texts with the wrong direction, the quality was going down. This is why we saw that Tesseract should be replaced with a different model. As a result of the testing, we selected the state-of-the-art whole model, which was pre-trained on English, and it was retrained on the Russian data massive, using the popular fonts. As a result, this function uses pre-trained Craft neural network to identify the text, and then Clover to identify the text, pre-trained on Russian and finally trained on Russian.
One of the objectives which can be used when using artificial intelligence, this can be done in order to compare the trademarks and the images. The computer vision has its own specific features as far as not only the visual identity has to be checked, but the number of categories which can be applied for may be numerous. Before the metadata-based search was used, Vienna principle was used, and besides, systemic data were used. This is the image search selected by the experts in order to make the examination. The most popular architectures of neural networks were used, such as EfficientNet and ImageNet. As a result of machine learning, the best results were achieved when using the Rosneft 50 architecture. When using the deciphers, big data search was to be done into the national system. As a result, the descriptor with 512 symbols was used, otherwise it won't be inefficient. The technologies used for the descriptors, this is metric, cosinus, distance, and rearranging using the expansion. This approach showed a good result, but not too high quality. Therefore, the following methods were proposed to generate the image transformation, such as vertical Gaussian rotation and accidental change of colors. XBM method was also used, and autoencoder was used. All these options actually showed a very good improvement for the search. In order to improve the quality of the search, the assembling was proposed. The testing was done on the basis of the validated sampling. The sampling was made on the basis of the real rejections, when the rejection or denial of the registration was proceeding from the identity or similarity of the applications. The experts also indicated the degree of the identity or similarity of the design of the image. The following methods were used. A set of 3 neural networks, ResNet-50 architecture, and this method was proposed by the experts, one of the most important ones, global average pooling method. This is number 2, and the third one is the gap analysis. These data were selected by the experts. Multisimilarity loss was used in order to use the cross-branch memory. Different combinations of methods were used at the moment. We are working on improving the functionality of the third stage to use the design-based search. And this is different from the trademark search. We use the contrast method. This is similar to CTGPT method, which is used for the text-based data. Here we used the same approach for images. So this is the teacher-less approach, which provided us with no results. One object may be described by several images, and therefore we had to design a solution in order to take all the images of the object in one set. It actually helped us to get an embedded image of the sample. We used the generation of complex samples, which showed very good results for the industrial designs. As a data for training and machine learning, we use the rejected applications. We also have a neural network clip visual transformer, or VITB/32, and mining of complicated samples for training, which is also called XBM. Multisimilarity loss and mining approaches are being used. At the moment, artificial intelligence is being used by Rospatent in its search infrastructure for patent information means of individualization or patent search. The artificial intelligence is being used in a number of the AI-based search machine translation, for instance, of English patents in the system of the search engine. It was launched in 2015. The translation is done using the Russian-based hybrid translation system, which uses the neural language processing and machine learning. And also it is an artificial intelligence-based approach. Also, it actually translates the SPC system into Russian. As a result of the artificial intelligence, our experts may actually take advantage of the international patents immediately after they emerge in the national patent offices. We can get the ready-made classifier in Russian, which may be updated several times a year. We work on looking for similar patents. We're aimed at, for instance, search for the documents which may serve as the foundation for the denial in the application, or identify the list of documents which included into the search. The similarity search was launched in 2017. At the moment, the search for similar documents is being done only for the Russian-based documents. So it means that we use the machine translation decision-making support system, natural language processing, distributed semantics, and rearranging or decisive trees lambda marked. We are using the multi-year work of the expert in order to achieve a high quality of document assessment. We are using FastText system with neural networks. This, as a result, we have a set of documents with similar results. Actually, this set of documents becomes available for the expert prior to analyzing examination of the documents. the terminology vector is being built, indicating the weights and all the terms. The thesaurus actually is looking for other terms and forms a query with extended search. So this is what we call the enriched search. Such documents being sorted and ranked can later on be rearranged. Rearranging is done using the decisive trees lambda mart, actually following the decisions taken by the experts prior to this very application. Extra methods are being used, such as rearranging using the boosting approach. For instance, well, actually, this is the click-based weights, other weights, and other parameters. Prior to the beginning of the work, actually, the accuracy was about 18% at the moment. Actually, the accuracy was increased to 60% after the boosting system is implemented. Actually, the accuracy would be raised to about 80%. Originally, we actually worked only with a set of Russian patent documents, but later on it was translated into English, and we will translate the multilingual documents. On that slide, I will speak about the implementation of artificial intelligence with Rospatent and the 3D IP system. This is the unique system. This is a visual representation of the IP in order to compare that and to examine the 3D models of the IPR. So we are using the 2D models on the merits. If suddenly the application contains the 3D model, every 3D model which is submitted for the registration, a descriptor is going, or histogram is going to be built to describe those 3D models. The lengths between some accidental dots on the surface of the models, then such 3D models would be used for the analysis using statistical models. A Siamese network actually would be used for the comparison. Two subnetworks actually would represent two samples, and the outcome actually will determine the vector. This objective is a pilot one, is experimental one, because the digital models actually are regarded as a subject for the IPR only starting from 2020. Therefore, the validation sampling would be done artificially, and it would be a bond between the machine and the expert opinion. In order to achieve efficiency in using neural networks, we'll have to use the big data accumulated by the IP offices in the previous work. The use of the state-of-the-art technologies allow us to call Rospatent as one of the most advanced offices in terms of the use of the AI. Thank you so much, Konstantin. Probably it was a kind of a provocative statement. You said that Rospatent creates something which is totally unique. Our next speaker, representative of China, a leader in terms of the bids and applications for the useful models, for the trademarks, and how the CNIPI is using these technologies, AI technologies. That's quite interesting. I'm passing the floor to Xin Chan, AI expert, Deputy Director General of Automation Department from the Chinese National IP Administration. Over to you.
Hello, everyone. I am Zhang Jing from the Automation Department of CNIPA. It's my great honor to share about the utilization of AI in CNIPA. In recent years, CNIPA mainly tried to apply AI new technologies in three areas. They are automatic pre-search, AI assistant formality examination, and automatic patent classification. The details are as follows. The automatic pre-search can recommend recommend related information such as classification information, keywords, and search query to the examiners for reference. This function is based on the data mining on massive search query data. AI technologies such as natural language processing and big data analysis are adopted. Meanwhile, the automatic pre-search can recommend related prior arts to examiners directly. For emissions, examiners input the number of the application they are searching. Normally, 400 related documents will be recommended. The related documents are sorted by semantics and ranked by similarity. In intelligent image search for designs, the system adopts deep learning algorithm. The system builds image feature extraction model and image feature comparison model. It can support image search based on the basic features such as color, texture, shape, and path. It costs 5 seconds per search on average. In automatic pre-search for utility models, the system can perform the automatic search and recommend 10 patent documents. It also provides content similarity by comparing the claims and the full text. According to analysis, for 13.8% utility model applications, the similarity index of the recommended documents can be above 80%. Now, I would like to share about AI assistant formality examination. AI technologies are adopted in preliminary examination, legal procedures examination for emissions, utility models, and designs. They can identify defects, give prompt messages, and even generate office actions. For legal procedures examination, about 60% applications are automatically examined by the system. For emission preliminary examination, the system can directly provide the accurate conclusion for about 45% applications. For design examination, the system can directly provide the conclusion for more than 10% applications. Next, I will talk something about automatic patent classification. For Lacano classification, the system can realize 90% accuracy for 90% designs. For IPC auto classification, we achieve 80% accuracy for subclass classification. Lastly, I would also like to discuss with you about the challenges brought by AI. AI offers opportunities for change in examination, but it is mainly IT staff's duty to explore the ways to combine AI with examination. This poses challenges to our IT staff. Besides, investment on AI is expensive, and we are expected to find a balance point between cost and performance for IP offices. So the second challenge is to maximize benefits AI investment. What's more, IP offices always prefer to foster its own IT team to tackle important IT issues, but the fast-changing AI technologies are hard to catch up with. So our third challenge is how to improve capabilities of our IT staff. And we are also thinking about how to combine in-house team with contractors in a better way. The development of AI technologies is still continuing. We believe exchanges and cooperation among stakeholders are very beneficial. So we are grateful that ROS Patent provides such a wonderful exchanging platform. We are also looking forward to more cooperation with IP offices and other stakeholders. In this way, IP offices can better explore potentials of AI and stimulate new momentum in IP offices. That's all for my sharing. Thank you for listening.
Thank you so much, Ms. Xinjiang. Thank you so much for this, your presentation. And if there would be any questions that we will ask dear colleagues. Saying that, I would like to redirect our discussion, diverting from the problem of use of the artificial intelligence in the work of the officers to the problem of examination of the applications for the AI solutions. Patenting and examination of IT solutions applications is far from being easy, and certainly it raises a lot of questions in many offices. And AI-based patenting and examination makes this objective even more sophisticated. Last week, such a discussion took place in the European Patent Office, and Mikhail Salnikov was our representative there. He's head of Physics and Applied Mechanics Department from the Federal IP Service. Michael, over to you. Really, it all goes around the artificial intelligence, and examination tries to follow this trend in the development of these areas. Our institute receives lots of applications which contain artificial intelligence, which are AI-driven. And certainly, these applications have to have certain peculiarities, and they have to meet certain requirements. A lot would depend on what object is to be protected by the applicant. Because, for instance, the artificial intelligence, this is the system which will think just like a human, and it has to make the decisions like human does. The only question is how actually the system is being implemented. We can implement that following certain recommendations, certain rules, so this is what is being done. And in essence, the artificial intelligence, so this is a set of rules which is being followed by machine, and a man actually has a totally different thinking process, where thinking uses certain templates. So once we see a piece of image, we'll see the bigger picture immediately. The problem with the artificial intelligence is different. It has to search, to use certain rules, and this is proceeding from its rules that it would take an appropriate decision. So it means that the artificial intelligence is about an intellectual activity. The conference which was mentioned by the European Patent Office hallmarked one of the ideas, and I liked it very much. So one of the presenters said that artificial intelligence, this is a very abstract notion. Really, this is a very abstract notion, and this abstract notion can be used in many areas. For instance, image recognition, what's been showed by other speakers, machine translation, neural networks, expert systems, machine learning. But usually it would be based on some abstract notions. And we, as experts, we take a decision following on the solutions which actually can be regarded as the technical solutions. So speaking about the IT technologies, for instance, there would be some design improvements. For instance, we take Intel or IBM computer and change the logics, not just 0 and 1, but also we make it not a binary system but tertiary system, or change something but processing the data. It would be a technological solution. Or, for instance, we have a computer and we have developed a software so that it would be using total different algorithm and would change something or would improve something. So it would be about a technical solution. In essence, the artificial intelligence can be used in all these solutions which I listed before. For instance, how the computation may work. We said that you may recognize images, and for instance, we would be using certain particular features of the computer in order to recognize images, doing that very efficiently with high accuracy. We can use artificial intelligence to steer or to run robots. For instance, we can be shown some dancing robots or some dogs carrying cargo. And these are AI-based technologies, but the artificial intelligence, in essence, if you try to protect that with legal means, it may be quite difficult, because any software, any rule is proceeding from some mathematics logics. It may translate into some mathematical expressions, or actually it would involve algebra, but you cannot avoid that because this actually proceeds from the mathematical logics. Or it may be typical of human inventions or creativity. And if the application tries to describe these things, speaking about mathematics, how a man has to think, most likely there would be difficulties and challenges in getting a patent for this invention or for the model. On that slide, I show the bonus, for instance, granting of a bonus. So this is an artificial neural network. So we took some microchips, certain elements which were put on those microchips, and we actually replicated the structure of neural network. We have every right to do that, and probably it can be regarded as technological solution, and the neural network would define who is a cat and who is a dog. It won't be it would be kind of a receiver or transmitter, but we can regard that as an artificial neural network, AI-based neural network. Another thing, for instance, we have to analyze certain information. For instance, we have certain spectrum, we have certain signals which prevent the system from working, and if we put these signals on the screen, and a man actually is there to identify what signals are detrimental, which are not. Certainly, this can be delegated to the artificial intelligence. And AI system would define what signals are positive, which are negative, which have to be neglected. So that's the solution in essence. And this is a joint work in terms of receiving the signals and their processing. And I just think that actually this can be regarded as a technical solution. In another case, so this is a season of forest fires. There was a situation when you had to analyze a big territory, so we'll launch a drone, and the drone will define whether this is a forest fire or not. For instance, it might be a fire with the big territory embraced by the fire, or actually maybe just a cigarette lit, or just very limited fire. So we have certain parameters to be guided by, for instance, the temperature and the scope. We may put people inside a helicopter, or it may be done, the analysis may be done by the artificial intelligence, and the artificial intelligence may decide whether there is a forest fire or not there. And again, such a system can be regarded as a technical solution, and if there are no contradictory things, then it can be patented. There is another category of decisions which are more controversial. For instance, that's the case of such a system. So if you read this slide, in essence, this is just nonsense. If you don't work with the applications, if you don't know how the formulas for the patents look like, it would be a total nonsense for a rank-and-file person, because you will see just a description of different assets, but actually this is a very abstract thing which has been described there, so an abstract thing which cannot be protected as an invention. If you look at the documents supporting the application, you will see that, for instance, this system, which is called the system of artificial intelligence-based data analysis, includes certain topics, and analyzing these topics, we may highlight this topic, another topic, and in essence, this is a search engine. Again, back to what's been written here. Now, this is the data analysis by the artificial intelligence, and it contains an algorithm with certain tools. And one or several such tools are AI-based. In that case, probably we'll consider the solution to be not technical. So this is just about analysis of the data, representation of the data, and what should be done for this sake. I would say that this is closer to the intellectual activity, but if the description indicates that, for instance, this artificial intelligence is using other parameters which were not used before, that it does some measurements, and if actually it's been included into the invention formula, then it can be regarded as a technical solution, meaning that apart from certain characteristics, it can be complemented with certain technical elements, and therefore this system most likely would be a technical solution. But this is not all. This is the very first part of the case. The second part of the case is that sometimes it happens that the applicants would like to get a broader patent in order to get more profit. But if you want to claim something, you have to prove that you have the right to claim that. And the data analysis should disclose that. And there would be lack of disclosure, meaning that the applicant didn't disclose how they are doing that. For instance, like there is a TV show at Discovery Channel. So you have to go into every detail, what you're doing, how you're doing that, because the patent is granted for the disclosure of the process that 20 years after the protection, any other person actually can do that and protect that as the main protection principle. So these are the challenges which we're facing when patenting AI-based solutions. And I call on you that in case actually you apply for AI-based solutions, please disclose as much as possible in your description. Thank you. Thank you, Mikhail.
Thank you. Thank you. This brings our discussion to an end. And to complete our session, I would like to invite Ms. Helen Bethlehem, Director of European Patent Office, to make her presentation.
Thank you very much on behalf of the European Patent Office for inviting us to speak in this conference of Rospatent. It's my pleasure today to discuss with you some aspects of patentability of AI-related inventions, as well as the use of AI tools at the patent, in the patent granting process. And I would also like to discuss a little bit the communication aspect of this whole topic. Of course, for the communication aspect, Rospatent has with this conference already taken a very good step to bring the information out to all interested people. I'm now trying to share my screen. I hope that you can see the screen and that it is visible to you all. Hoping that it comes up. So now to start with the presentation when the screen comes up. So at the European Patent Office, some of the previous speakers have already been mentioning some aspects of patentability of AI and the use of AI-related tools in the patent grant process in the previous presentations. I will start, as I said, with the patentability of AI-related inventions and then add some further aspects of the use of tools. So, we are all here today to discuss patent law and AI. And of course, one crucial topic here is that I think that even the fact that we are having the conference here today shows that patent law as it stands, it is in the position and is adaptable to also accommodate inventions which are now the new ones, so the new and emerging technologies, like it has been doing in the past industrial revolutions. We are now talking about the fourth industrial revolution. Of course, one question that was also mentioned by some of the previous speakers is the question, definition of AI. What is AI? What are we talking about here? So actually, there is not yet any fixed common joint global definition for AI. We have seen in the previous months a lot of studies from World Intellectual Property Organization, from the US Patent Office, from different private enterprises, universities, from World Trade Organization and so on. And all these are using a little bit different definitions of AI. At the European Patent Office, we see AI as a broad subfield of computer science that covers many different computational modes for solving data analysis problems, empowered by software capable of reproducing aspects of human intelligence. So this is how we see it. Of course, AI then encompasses computational systems, for example, machine learning, but AI systems, they are software-based. We are talking about voice assistance, speech, face recognition, or we are talking about those AI systems which are embedded in hardware, for example, advanced robots or autonomous cars. So for the European patent system, these inventions related to artificial intelligence and or machine learning fall clearly under the definition of computer-implemented inventions, abbreviation CII. So, of course, we can categorize the AI inventions to different categories. And the first two ones here on this slide are definitely not a question. These are something that we are used already to have in our households even, and in our cars and everything. So some devices where AI is used for the verification of the outcome, or where the human identifies a problem and AI helps to find a solution to a problem. And this now in the inventive activity. Of course, what is a question of the future is the question of independent AI, where AI itself or AI system, machine learning system would then identify a problem and also propose the solution according to the problem solution approach that we are using. Of course, patentability requirements, as the previous speaker also explained, we are patenting inventions in all fields of technology. So when they fulfill the criteria of patentability. And there are some new inventive susceptible for industrial application. And of course, there are then some inventions which are, or some categories which are not seen as inventions, and some which are then excluded from patentability. So when we look about those that category, what is excluded from to be an invention in the sense of patent law. Of course, then we come to the very focus of patentability of CI and artificial intelligence related inventions. Here at the European Patent Office, it is the crucial point is the phrase if claimed as such. So if the invention is run on a hardware or is somehow in context of hardware, then the first hurdle is overcome, because then it's no longer claimed as such. But then we come to the second hurdle, as it is called, namely that only those features which are technical are relevant for the assessment of inventive step. This has been very recently in March clarified in a decision of the highest instance of the European patent, or the highest judicial instance of the European patent system, the Enlarged Board of Appeal of the European Patent Office, in its decision G119, where it made it clear that this is the approach also to be used in case of computer implemented simulations, and which often also applies in relation of AI inventions. Here we, so that is the so-called COMBIC approach on basis of a decision of the Technical Board of Appeal. What is important here is that our Enlarged Board of Appeal did not give a definition what is technology or what is technical. So that is left for further analysis and not analysis, for further development of technology and technical, what can be seen as technical in this sense of patent law. Important question on the patentability of AI-related inventions has often been the question of disclosure. What is sufficient disclosure? How can the person skilled in the art derive the relevant information from the patent application? We all keep in mind here that the patent system is also to disseminate technical information. And in order to disseminate technical information, the person skilled in the art has to be able to derive from the application any feature essential for carrying out the invention in sufficient detail to render it apparent to the skilled person how to put this invention into practice. We have already got clarifying decisions from our Technical Board of Appeal on that. And these two decisions, which I mentioned here, make it clear that it is not necessarily relevant to file the whole data set, for example, together with the application. It might that would also be a burden for the patent system. However, the patent application needs to define what kind of data is used, how it is used in the invention, and what purpose it is used. Not the whole data set needs to be filed, except in maybe some very exceptional cases where that would make it relevant for the person skilled in art. Therefore, with this approach, there is also not the necessity to disclose the whole algorithm in the application. It could be, but in most cases it is not. That is, of course, the question of the scope, what is claimed, but it needs to be sufficiently disclosed. So we used to get, years ago, when the first AI-related patent applications were filed, we used to get the applications which said something like, this is achieved by machine learning or by neural network. Of course, that is not enough. It needs to be defined in the application, what kind of neural network, how that is operated. But with this approach that is here, the sufficient disclosure in the application would make it, as the previous speaker explained, would make it enough then for the future generations during the next 20 years to derive the relevant information during the lifetime of the patent to get it from the application. And therefore, the deposit system which might be very difficult to implement, to get the global agreement for it, and also to make it clear in which cases and how it is to be used, to whom the deposit system would be open, who can get information from the depository, and how and what are the fees. So, but of course, when applying the basic principles, that would not be so much of an issue. Something that has been discussed often also in the context of AI-related patent applications is the person skilled in the art. Here, the wonderful aspect of the person skilled in the art as a legal fiction is that the person skilled in the art is a fiction. And as in Europe, the jurisprudence states it very clearly, and even our guidelines for examination explain it very clearly, it can be a team. So there can be somebody who is in the technical field, let's say, for example, a plant breeder in biotechnology, and then somebody who knows how to program or how to use AI in order to see from this, with AI tools, the crossing and selection process so that there is going to be a good apple with a certain technical feature in the future, for example, a nutritional feature. So that as a very far-reached example, but of course, AI, I wanted to demonstrate with that AI will be there in all fields in the future, in all fields of technology. And at the European Patent Office, we have the 3-member divisions where we can have experts from various technical fields. Then, of course, the very interesting question here has been the question of inventor and whether a machine or a computer program can be an inventor, because there were cases filed, the so-called DAPUS cases, where it was AI system was designated as an inventor. In those cases, different instances overall in the world have given their opinions that a human being needs to be an inventor. That is also something that is to lead us in then to the discussion in the next session, because of course, when we talk about patents, when we talk about inventions, in the European Patent Convention we say, and in many national patent laws in Europe, it is said the right to the invention belongs to the inventor. So when we talk about rights, the legal framework, the legal principles say that only natural or legal persons can have rights and can have obligations. And of course, behind a legal person, there is also then a human being, a natural person as well. So therefore, there is a need to see how the societal development goes here, so that to see, can patent systems start to grant rights to machines or computer programs, or do we need to wait when the societal development and the legal framework is far-reach enough that there is an agreement that rights and obligations can belong to something else, for example, to a computer program. And of course, here we can then start the discussion about self-driving cars and what happens when there is a tree on the road or on the side of the road, as we have maybe seen in the news in the recent days. So this is also something that is the human-centric approach to artificial intelligence that has been endorsed very closely or very thoroughly by the European Parliament and the Commission. And here it is also something that the European Patent Office follows. We are going to implement full scale this autumn. We are already using machine translation, as we heard from the previous speakers. The EPO has been for a long period already now using machine translation tools in the patent system. We are going to introduce a full-scale pre-classification system. But what is important for the European Patent Office in light of this human-centric approach is that there is always then human in charge. So it's going to be a pre-classification by AI, and then there is a human examiner who will be looking in any case, examining the application and then checking also the classification. In this context, I would also like to draw attention to the guidelines for examination, where we have every year more and more. Now 2021 edition has even more information about guidelines. And in the same context, I would like also to draw your attention to the bilateral studies that we have been doing with Japanese Patent Office, Korean Patent Office, and Chinese Patent Office, which so the Japanese study is already published, the others, the publication is in progress. And also in those studies, we have bilateral evaluation of how patent applications are dealt with relating to AI in the different patent offices, so in those bilateral patent offices. And here there has been very good cooperation between the offices, and I truly hope that we can continue the same cooperation even further, and to look into that topic also in with different offices, because as we heard from the first guest speaker today, from Helen, it is important in these new technologies and emerging technologies that we all work together and that we all communicate together also, and each of us communicates like you are doing now, Rospatent, to the users of the system, so that there is global understanding and everybody can use the patent system to its best in this technological area. With that, I would like to thank you all for your attention.
Thank you so much, Heli. So the human-centric approach certainly is very close to our hearts, and in the end, certainly that should be a human being. Dear colleagues, we are completing our session, our discussion. Several times, many speakers said that inevitably we'll have to use artificial intelligence with some kind of predetermination. This is inevitable, just like we're using internet and automobiles and aircrafts. One protagonist said that automobile, this is not a luxury, but just a means of transportation. So artificial intelligence, this is the way our patent offices can progress in future. Thank you.